Let us review the parabola, its important properties and formulae. So the definition of the parabola can be stated like this. It is a set of all points in a plane that are equidistant from a fixed line and a fixed point. The fixed line is called the directrix and the fixed point is called the focus of the parabola. Now, the standard parabola is drawn like this. It opens to the right and the equation of the standard parabola is y squared equals 4ax. Now let us review the important formulae connected to this one. So this is the equation of the parabola. The vertex is given to be the point 0, 0 and it is at the origin. The focus is the point a, 0. The axis is the x-axis whose equation is y equals 0. The line x equals minus a is the directrix and we can see it is situated to the left of the parabola. The length of the lattice rectum is 4a and the focal distance is x plus a. The focal distance is just the distance of any point on the parabola from the focus. There are other forms of the parabola. So if a parabola opens upwards, its equation can be taken as x squared is equal to 4by, and in this case the roles of x and y interchange completely and the vertex is still the point 0, 0. The focus is now at the point 0, b. The axis is the y-axis whose equation is x equals 0. The directrix is the line y equals minus b and we can see that the directrix is now a horizontal line. The lattice rectum length is 4b and the focal distance is y plus b. The concept of tangent is important in a parabola. So if we have the standard parabola y squared equals 4ax and if we want to write down the equation of the tangent at a point x1, y1 on it, then we write it down like this. y1 is equal to 2a times x plus x1. Now there is also a condition for tangency. So if we have a line y equals mx plus c, then this line would be a tangent to the standard parabola under this condition. So c should be equal to a by m. And this line is a tangent at the point a by m squared, 2a by m. Now the rule for writing down the tangent is same as for any other conic section. So the rule is that we have to replace x squared with x1, y squared with y1, 2x with x plus x1 and 2y with y plus y1. The normal is the line which is perpendicular to the tangent at the point of tangency. So if this is the standard parabola, then the normal at the point x1, y1 is written like this in the Cartesian form. Another important form of writing the normal is this: y equals mx minus 2am minus am cubed. M here stands for the slope of the normal. It is not the slope of the tangent but the slope of the normal. And this line is a normal at the point am squared, minus 2am. The parabola has parametric equations. So we say that x is equal to at squared, y is equal to 2at. So t here is the parameter and we say that this one represents the point t on the parabola. The equation of the tangent at the point t is given by this expression. The equation of the normal at the same point t is given by this equation. Now parametric forms are useful in solving certain questions. If you have to write down the equation of the chord joining two points p and q whose parameters are t1 and t2 respectively, then the equation for that is given by this one. Now this chord will be a focal chord if it passes through the focus of the parabola, which means the condition for the focal chord is t1 times t2 should be equal to minus 1. The tangents at the points P and Q, they would intersect, and the point of intersection is given by this one. So a t1 t2 comma a times t1 plus t2. There are some useful properties related to a parabola. The first one says that the tangents at the extremities of any focal chord, they intersect at right angles on the directrix. Then related property is that the locus of the point of intersection of perpendicular tangents to a parabola is always its directrix. And finally we have, in general, there can be three normals that can be drawn from any point to a parabola.